So I'm going to talk about basically the economics of critical minerals, with emphasis on rare earth elements. And we've seen some work already that Matt Valentich has already talked about, and what Paul and some of our metallurgist friends have talked about in terms of the potential um, of certain types of deposits to actually have significant rare earth elements within them. The question obviously be, can they be recovered? What I'm going to actually do is actually look at the potential value of these things. And yeah, so I won't go through this very long, but critical minerals. Um, we've already had a definition, but there are actually three types of supply risks. The first one is geological, a restriction of mine supply or resources to a certain specific countries or companies. For example, cobalt in the Republic of Congo. Second thing is a technological limitation on extraction technologies, which we've just seen of talk about. A third thing that actually is not really thought about, but Rick alluded to it briefly earlier, is a political supply risk. And in this, there's a number of different ways. So there's a concentration or limitation of processing facilities. For example, Rick talked about germanium being Belgium being one of the main germanium producing countries in the world, but without any mines. It's because the smelting capability of zinc ores is actually concentrated. There's a lot of zinc smelters in Belgium, and they actually extract the germanium. Whereas in Australia, we don't extract the germanium. So if we send zinc concentrates out to Belgium, they'll probably get the germanium, and we might not get credit for it. And that means dollars or recognition that it comes from Australia. There's other issues, environmental concerns. There's, if we had the iron leach deposits that they have in China, would we actually be able to develop them? There's also NIMBYism. And the other thing, which has also already been alluded to, is that criticality is in the view of the beholder. Australia has a different view from the United States or Canada, and we all have a different view from China. So China might actually have quite a different list of critical minerals than what we have. Okay, so the next question, I think, is a very legitimate question, is what's government's, that is GAs and GSQ's role in critical minerals? And we've seen a bunch of talks about how government is trying to help us out looking at this thing. And the first thing is to identify opportunities and providing support to unlock Australia's and Queensland's potential as a critical mineral producers. The other thing is promoting Australia as a reliable global source of critical minerals. We are a stable country. We don't really have a lot of enemies, and therefore we're likely to be a relatively consistent supplier of critical minerals. The other thing that we're doing, and Vlad alluded to this in his talk, is documenting the abundance of critical minerals in Australian ores and also in mine waste. And we saw a bit of that in Paul's talk just previously. We're also going to provide pre-competitive data and concepts to assist mineral explorers. We have to remember that critical minerals are commonly byproducts of major metals. So we have to discover the deposits of the major metals in order to get the critical minerals. And the other thing, and as I say, Vlad talked about this, is collaboration with other international agencies. And this includes the critical mineral mapping initiative with USGS, GSC, and GSQ. Okay, I'm going to have a very brief comment on exploring for the future. It's already been alluded to. We're actually going through the final stages of deciding our work program, but we can't really talk about that until our minister announces it. But as people will have known, in June this year, the Australian government announced $125 million investment in the Exploring for the Future program. And this will happen over 4 years. And then in August 2020, the government announced that there's to be concentration on two corridors, one in the east and one on the west. And then there are also some national projects, and that will become what exploring for the future is. And there are some things that will happen in Queensland because of this. So just keep your eye out for what's going to happen probably in the next couple of months when our minister makes the announcements. Okay, now this is a diagram that Matthew Ballinger showed us before, just looking at the concentration of rare earth elements normalized to a shale. And he's just noted on the bottom there that those dollar signs are just the price of various critical commodities or various rare earth elements. And you can see there's a lot of variation in that. And so what we did was we took the analyses that Matthew provided for a couple of the deposits, and we actually calculated the value of the rare earth oxides. We calculated the amount, or we took the analyses and determined the amount of rare earth oxides, and then we actually got the rare earth price. And it's actually in a uniform, it's US dollars per kilograms. Sometimes these are priced per ton, sometimes even by gram, but you can see that there's a large variation from $600 or so US down to about $2 for samarium. So there's quite a large variation in the prices of rare earth elements. But when you actually take those analyses, and this is on a per ton basis, it turns out that there are about $300 from this sample of Ardmore worth of rare earth oxides within that. And that's actually in comparison with about $75 for the actual value of the phosphate in it. If you do a similar thing for Phosphate Hill, it's not quite as strong, but you're still looking at $34 a ton value of the rare earth elements in those ores, as opposed to the $75 or so that you have for the phosphate rocks. So the rare earth elements actually could make a very significant difference to the economics of developing these resources. The only thing is that we have to have a way of getting them out. So it provides some opportunity and an indication of the potential for this. And just as I said, there's a number of things that you have as a potential value. So for a high grade deposit like Ardmore, you're looking at about $300 US per ton, whereas for Phosphate Hill, you're looking at perhaps at about $34 per ton. These are going to fluctuate a little bit because, well, the grade's going to fluctuate, but also the price of rare earth elements also fluctuates. And these were calculated at beginning of September this year. Okay, so we've actually taken that idea and we've actually looked at a radar diagram, which you see over here. So on the left, we have a radar diagram where the concentrations have been continental crust normalized. And you can just see on the diagram, and hope you can see my arrow, that, you know, relative to continental crust, all of the rare earth elements are actually enriched, but some are more enriched than others. And the interesting thing about this is that the heavy rare earth elements have a similar or even higher enrichment than the light rare earth elements. And as we know, on average, heavy rare earth elements are actually worth a lot more than light rare earth elements. And if you look at this diagram over here on the right, we've actually normalized that in terms of dollars per ton. Okay, so if you look at this, you can actually see that the value is in the dysprosium and the neodymium at Ardmore and also Phosphate Hill. So you can see, you can get a feel for the value of the different rare earth elements. It turns out samarium is probably not even worth thinking about, and the same for some of the other light rare earth elements. The value is in neodymium, dysprosium, and lutetium, and to a certain lesser extent, terbium and gadolinium. So that's actually an interesting thing. The other thing is you can actually compare Ardmore in the green versus Phosphate Hill, and the assays say that Ardmore is worth more than Phosphate Hill. The other thing we can do is we can actually we can compare it with other deposit types. And so here we have a comparison with Olympic Dam. And so you can see that relative to Olympic Dam, the phosphate deposits are actually heavy rare earth element rich, whereas Olympic Dam tends to be much higher in elements like lanthanum and cerium, which are the less valuable things. And you can actually see that in terms of our Scrooge diagram over here, which indicates there's actually a lot more value in the light rare earth elements at Olympic Dam relative to what you see at Ardmore. So there are some differences in terms of the value of the rare earth elements. So in a sense, not all rare earth elements are equal. And so you need to think about that as you're doing that. The other thing that we've been able to do is to actually assess the viability. How does this affect the potential viability of development of the resources? And so we've developed what we call economic fairways, which is a tool to assess economic viability. And this diagram here just looks at viability as a function of transport, shipping, a road, cost, energy costs, royalty costs, mining costs, and also an important determinant is the thickness of cover. As you might imagine, it costs a lot more money to mine through a thick cover than it would if the deposit was outcropping. So actually, we consider all of these things, and then we make an assessment, and this is an assessment based on a deposit of 4 million tons of 2% copper and 3 grams per ton gold. So it's a small deposit, but relatively high grade. And if you can actually look at this diagram here, it shows the net present day value of this thing. So at 0, the white, that means it's a break even. If it's red, it means you make money for this thing. And you can actually adjust the deposit size and grade to see, to change things. So we've done the same thing for the phosphate deposits. Okay, and so I'll show you an example of a large deposit, and this would be Phosphate Hill. This is the pre-mining resource that they had a long time ago, and so we've got a 1.4 billion ton deposit, about 18% phosphate. The value of the phosphate is assumed to be $88 per ton. You do the sums, and the light pink indicates where it's viable. And as you think, I think Phosphate Hill is sitting down in here, so it is within the viable range, and that's actually consistent with the fact that there's a mine there now. So if we take the analyses that we've already had, say 1% or 0.1% rare earth oxides, and we assign a value of $40 per kilogram to it, suddenly everything turns red. And so a deposit like that would be very viable pretty much anywhere in Northwest Queensland or into the territory. So just looking at that, it suggests that the rare earth element addition, as long as you can get it out, actually will make quite a significant difference. The one thing you can see on this diagram here, the dark brown or dark red here to moderate red here, that's actually due to the fact that the royalties in the Northern Territory are slightly higher than the royalties in Queensland. So if we go to the next one, and we take the Ardmore case, and we go back to the literature, and we find that Ardmore has a great size of about 47 million tons at about 16% phosphorus. We do the same sort of assumptions, and then we actually add the 0.9% rare earth element oxides to that. And again, you go from very, very marginal to sub-economic. In the case of Ardmore, pretty much anywhere you look in Northwest Queensland or in the territory, it's very marginal or sub-marginal. But if you add the rare earth element concentrations that we know are within that deposit, suddenly it becomes extremely viable. So the addition of the rare earth elements can actually make a lot of difference in terms of the economics. The other thing that we've done is we've actually calculated in-ground values of other critical commodities. Okay, so I've just taken a sample from Mount Isa, and this is from publicly available assays from the Osanaka database that was put out by the University of Western Australia. And so actually, if you took this particular sample and you do the actual costs, it turns out that there's a significant amount of value in the cobalt in this particular sample. It turns out to be about 12% of the value of that sample. So you actually could have significant amount of money available from if you recovered the critical minerals, or in particular cobalt. So we do the same sort of thing. We go to the Mount Isa zinc. We take another sample, and it turns out that about 6% in this case of the value is actually within the critical minerals, in this case germanium. So there's about $50 or so worth of germanium in that particular sample. So again, 6%. If we go to another sample from George Fisher, we find, again, there's a significant amount of critical minerals. Again, it's mostly germanium, in this case $80, and it's actually about 20% of the value of that particular sample is in the germanium. So Mount Isa and George Fisher potentially are significant germanium resources. I don't know if the germanium is extracted when the concentrates are shipped overseas, but it is a potential source. There's a couple of caveats on this. Number one, if the critical minerals can be recovered, I would think that they are material in terms of the JORC code. And number two, there's a bit of caution here. The samples that we've used from the OSNACA database are not representative. They were collected by geologists who tend to like pretty samples or weird samples. And so they're indicative, but not representative. So if you really wanted to work out exactly what's going on, you'd have to have a fairly systematic study. The other thing that we need to think about in terms of critical minerals is the size of the market. And so here what I've done is I've just indicated the number one, the price here, the production per year, and this is from the USGS in 2018, and a document that Gavin Mudd put together for us last year. And we just look at the production, the price, and then multiply that by that, you get market value. And for copper, just as an example, it's $121 billion. Zinc, it's about $37 billion. If you start looking at some of the critical minerals, you're looking at 24 billion. If you look at phosphate rocks, you're looking at 20 billion. But these things are not too dissimilar in terms of the size of the market. Zinc. If you look at cobalt, it's smaller, and molybdenum is smaller. If you look at germanium, it's a very, very small market. So that's something that you have to think about when you're looking at these things. So you certainly have a big supply. I don't know where that heat is coming from. If you certainly have a big supply of germanium, what's that going to do with the market? Which brings me to the last point I'm going to make. And this is the opportunities and the risks of critical minerals. And so what we have is a sort of variation in prices of cobalt. And we can see if you're at the beginning of that trend, the market increases, and you actually have a big opportunity to make a lot of money. But in contrast, on the other side of that peak, there's a lot of risk actually losing that money. And a lot of critical minerals are going to behave exactly like cobalt, or as we're seeing now, lithium. So that's something that we have to think about in terms of this. So in terms of conclusions, for Australia, critical minerals represent an opportunity to provide supply. Critical minerals for Australian economy, I didn't talk about this, are limited, but are mainly agricultural related. So as I said before, different countries have different critical minerals. For Australia's economy, it's agricultural related, which is actually good because potash would be a critical mineral, and also phosphate, which is what we've been talking a lot about today. The extraction of critical minerals can positively affect the viability of resource development for some deposits, but again, that depends on the technical viability of resource extraction, and also the concentrations, deportment, and spatial distributions are not known for many of these critical minerals. And then finally, most critical minerals have small market and are subject to unpredictability of such markets. And I think I'd like to highlight the fact that if you have a major commodity where you have a relatively stable price and the critical commodity is being extracted as a byproduct, then you actually have a significant insurance policy. So with that, I'll answer any questions. And after that, we can go and talk about the demonstrations if people want to do that. So I will.
Thanks, David.
Yep.
Well, there is a question online, so I'll ask you that in a second. What I might also, well, I'll confer quickly with Helen here, but we were already 6 minutes over time through no fault of yours, I should say, through the fault of others, me. What do you think?
Okay.
I'll ask the question, but what I was thinking was maybe if you just quickly show, rather than, I don't think we have time for 15 minutes of an exercise. I think maybe if you just show what you wanted to show with the people have got a copy of the spreadsheet. So you could show that, but before we do that, there's one question online here, and it's one I wanted to ask as well. And that is that the economic viability plots for the phosphorites, the question is, do they take into account the cost of rare earth recovery from these?
No, they don't. No, they don't. That's just the raw in-ground value. So when you that comes into whether you can actually extract them for reasonable price. So that's something that you have to consider. And so obviously it would be a much more significant problem for a Phosphate Hill ore than it would be for an Ardmore ore. So yeah, that's, I guess, you and the School of Mines at EOQ. That's the problem that you guys have got.
Yep. No, good. Thanks. Are there any questions from the room? Yes, we've got one here.
This is more of a comment than a question, but so I've recently had a look at germanium and spoke to a couple of chemists, and it turns out that your normal ICP-MS actually isn't very good at germanium because it's highly volatile. So if you're looking at germanium, you need to use a low temperature digest. So it's just a word of caution and comment. I wasn't aware of that until fairly recently. So I think with all these, elements that we're not normally or not familiar with, it's just important to make friends with your chemist and know what you're analysing for. Otherwise, it could be quite misleading. You might have, those Mount Isa examples. There might be more there than you expect if they were analysed through a normal ICP-MS. Okay,
I believe we talked to our chemist and he was okay with it. But yeah, I agree with you that is an issue. As you say, the concentrations would actually be higher, and so would have more value potentially if the analyses are incorrect. So anyway, do you want to have a quick look at the calculation spreadsheets?
Sure. Yeah. If you just, I think at this stage, because we've run over time, to just sort of show the like the wrap up answer rather than exercise. Sorry about that.
So what I'll do is so you have on this thing on your you were given on your stick a copy of this data set here, which is basically OSNACA data set, which you can actually download from the University of Western Australia website, and it just indicates the concentration of various minerals. And what I've done is I've ordered these things in a particular way so I can actually copy.
I was just going to say, David, we can't see it. Are you going to show put it up or?
Yeah. Okay. I think it's a problem with me. Oh,
Yeah, if you actually share your computer screen rather than a
Okay.
window, then that should then it'll show whatever's on your computer screen.
Okay, can you see it now?
Yes.
Okay, so what this is the Osnaka data set. And so in the yellow, I've actually taken a sample of an IOCG deposit from Artemis, and I don't even know where it is or anything like that. And so these are your analyses for copper, silver, gold, platinum, palladium, blah, 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 blah. And so you just copy that. And then I'll go to the calculating values, and you go to the copper rich ore calculations, and then you paste special. And in this case, you have to transpose, and it will actually go and calculate the total value of that particular sample in terms of per ton of sample. It will actually calculate the the value of the critical minerals. In this case, it's mostly cobalt, and it will actually calculate the total critical mineral as a percent of the total value, in this case, about 7%. And so we've actually got ones for rare earth elements. We've also got one for zinc-rich ore, and for different commodities. And so you guys can play around with that as you see fit. And yeah, it's an interesting thing there. You get some surprises. So just go through it and have fun. Okay, so that's
great. Thanks,
me.
Thanks, David. I was thinking as you were showing that, well, if people get nothing else from today, I'm thinking they'll get a good spreadsheet that allows them to do that, because I often sort of get to this point and go, oh, I don't have a spreadsheet that's got the latest metal prices. So no, that's great. Thanks very much.
The one thing is that the prices are early September.
Yep. Yeah, that's, yeah.
Okay, because it changes. And one thing I'd like to do is get some of our computer whiz kids to develop a thing where they can actually go to the web and pick out current prices, so this thing becomes self populating.
We should talk about that. I think we can do that. I think we've done that, but I'll have a check.
Yep. Okay.
That's great. Thanks a lot.
Okay, so I'll stop my sharing. And thanks for everybody. And I'm glad I'm not in Mount Isa right now. It's nice and about 24 degrees in Canberra. So